Part 2, Model. This model suggests how everything in our universe was made from photons, light energy. Photons converted to matter through pair production, E=mc². Start with the Big Bang that expanded out of Dimp, the dimensionless point. That started pair production that made all the elementary particles that make up everything else. Pair production is when photons, light energy, make matter, usually an electron and positron, or anti-electron, pair. But under certain extreme conditions, neutrino and antineutrino pairs, or proton and antiproton pairs. Best example today on a very small scale is virtual particles. They are an electron and positron pair that pop up everywhere in space, then almost always immediately annihilate back into energy. So why didn't the pairs annihilate during the Big Bang too? My suggestion is that space was expanding at such a phenomenal speed, the temperatures were so high, and the electromagnetic field was so strong that the particle pairs made by photons separated in the expanding space and then reassembled to become fundamental particles. So during this first extreme phase of the universe, the particle pairs were separated and did not annihilate. That allowed the building blocks for our universe. Best example now is plasma, one of the four states of matter where negative and positive particles are separated. Or Babb scattering, where an electron-positron pair turn into a photon that turns back into a positron-electron pair. Or electromagnetic showers, cosmic rays of photons that make positron-electron pairs that make photons that make etc., etc. This phase of extremely high temperatures and extremely quick expansion made neutrinos, electrons, and protons that in turn assembled to make everything else. Photons from Dimp created quantum pairs that created the universe. Photons produced all 6 fundamental particles and antiparticle pairs, including the neutrino and antineutrino with no charge, the electron, negative charge, the positron or anti-electron with positive charge, the proton, positive charge, and antiproton, negative charge. Next made was the combination particle, the neutron, no charge. The neutron is not a fundamental particle. This hybrid particle had either a mix of proton and electron equal no charge, or a mix of antiproton and positron equal no charge. My suggestion is that the neutron hybrid could be formed in a way similar to the process of electron capture, where a proton plus electron equal neutron plus emission of a neutrino. Here are the fundamental pairs made from the Big Bang. Charges are positive, plus, negative, minus. Electron, negative. Positron, plus. Proton, plus, minus, plus. Antiproton, minus, plus, minus. Neutron, plus, minus, plus, minus. Antineutron, minus, plus, minus, plus. The protons and neutrons are made from electrons and positrons. When this production of particles was over, most antiparticles with charge, positrons and antiprotons, didn't exist on their own. They were locked into protons or neutrons. That way, conservation of charge was maintained. That also explains the missing antimatter problem. Neutrino, no charge. Antineutrino, no charge. Neutrinos have no charge and are weird, small, fast, extremely light, and confusing. Photons and pair conversions usually make electron and positron pairs, but in certain extreme conditions, photons can make a neutrino and antineutrino pair. They act like chargeless electrons or positrons that are not fully formed yet. Perhaps they are the first fundamental particles made. Or perhaps, re-examining beta decay, neutrinos may not be needed at all. Or perhaps they are something little understood even yet. What this model may resolve. Why a proton and electron have the same charge. Why a positron and proton have the same charge, though the proton is so much larger. Why the missing antimatter is in the protons and neutrons. Why neutrons could form from either protons plus electrons or antiprotons plus positrons. Why the collective charges in the nucleus never exceed more than one positron for every electron, except in ions. Why the strong force may not be needed. Why there is a proton and electron released in beta minus decay. Why a proton electron can form a neutron in a neutron star. Why a proton needs a neutron in every atom except hydrogen. Why the neutron tail, the extra negative charge on the neutron, is so important. Why electron capture. Why there are so many neutrinos. Why neutrons have a magnetic moment. Why neutrons have negative charge on edges but a positive charge between. Why free protons last forever but free neutrons last about 15 minutes. Why there are problems with quarks. Why inflation happens. How conservation of energy is kept. How conservation of charge is kept. Why the singularity was photons and the force out of the singularity was particle pairs. Why the production of equal amounts of matter and antimatter didn't annihilate each other, or why is anything here? 6 phases of the universe. 1. Big Bang. 2. Fundamental particle production. 3. Matter building. 4. Acceleration of space from dark energy. History of the universe. As more and more matter was clumped together, there was less acceleration and a slow dark energy expansion. This lasted for the first 7 or 8 billion years. That is now being followed by less new matter production and more dark energy acceleration. So the expansion of the universe is speeding up. End of part 2.